Homework 9, Section 5.2, the addition rule, complements video 7. This is the final video for this homework assignment. We're going to talk about complements, and although I kind of defined them earlier as the complement of this event is the event that the first one doesn't occur, I would like to define it a little bit more rigorously in terms of some definitions that we laid out in the previous homework assignment. Two events are complements if they have no outcomes in common, but together they make up the entire sample space. So for example, let's say that we have a sample space that consists of, we'll say A, C, D, and S. And if you're wondering, well, it wouldn't be A. What am I missing? H. I'm going to change the A to an H. Hearts, clubs, diamonds, and spades. Let's say that event A is you draw a heart or a diamond. In other words, you draw a red card. The complement of A would be the events from the sample space that were missing from A. So what events from the sample space are missing from A? Events C and S, or outcomes I should say. Clubs and spades. And you know what? I really shouldn't have used capital letters because capital letters represent events. So I'm just going to change them to lowercase to represent abbreviations for hearts, clubs, diamonds, and spades. A very minor thing, but it's just bothering me. But complement just basically means everything that's not in the first event. So they have nothing in common, but together they have everything. It's like the world's cheesiest love story. They had nothing in common, but together they had everything. Cue sappy music. All right, so what's the deal with complements? And specifically, what's the deal with complements and their probabilities? Let's take a look at another example. Let's go back to the contingency table. So previously, we had said that A is, I want to say it was likely to vote. I honestly don't remember earlier if I said A was likely to vote or if A was favored to bill. Let's just say it was likely to vote. And we had the probability that someone was likely to vote. I believe it was 731. No, 721 out of 1,000. So two questions. What is event A complement? And, this is an A, what is the probability of the event A complement? Well, the answer to the first question is easy. If event A is all the people who are likely to vote, then A complement is the people that are unlikely to vote. But how can we calculate the probability of A complement? In other words, the probability that someone is unlikely to vote. We don't know how many people are unlikely to vote. Or do we? We know there were 1,000 who were surveyed and 721 were likely to vote. So how can we calculate the number who are unlikely to vote? And the answer is subtract. Now, there's two ways to view the subtraction. Let's take the path that I've taken us down. There are 1,000 minus 721 people unlikely to vote. So the probability of A complement is 1,000 minus 721 over 1,000, which is 279 out of 1,000. Let me double check that. Yes. But what if our probability were not given as a fraction? What if it were given as a decimal or percentage? Then we wouldn't know how many people were surveyed out of the total. And we wouldn't know what the numerator was. And we wouldn't be able to do that subtraction problem. But there's a way around it. And the way around it is embedded right here. Because if I take this expression and break it into two denominators, two fractions, with the same denominator, in this case 1,000. First numerator is 1,000, second numerator is 721. That first fraction is just equal to 1. So 1 minus 721 over 1,000 is equivalent to calculating the probability of the complement. But wait a minute, isn't 721 out of 1,000 just the probability of the original event? And from this example, we can extract a rule. The rule's kind of embedded, but it basically says the probability of a complement is 1 minus the probability of the event. Don't worry, I'm about to write it on the rule. Sorry, on the board. Sorry for the squeaky shoes. I keep worrying about erasing it in case you forgot to write something down, but this is a video and you can always back it up. So there's a rule for complements, and it's a very, very, very simple rule. Rule for complements. The probability of a complement is equal to 1 minus the probability of A. Equivalently, you could put the minus the probability of A over here, and you could say the probability of A plus the probability of A complement is equal to 1. Now, why did I want to rewrite it like that? Well, aren't an event and its complement mutually exclusive? Yeah, there's no way something can happen and simultaneously not happen. So they are mutually exclusive. And didn't we have a rule that said if you're mutually exclusive, then there's a relationship between your probabilities? You could stick them together and put an or between them. Doesn't this make sense? The probability that something will or will not happen is 100%, because it either will or it won't. So it actually makes perfect sense that the probability of a complement is equal to 1 minus the probability of the original event, because the probability that it will happen or it won't happen must be 1. And that's it. Go try the homework. Text me if you have any questions.